Till now, you have learned the important library functions of Arduino. In this lesson, you learn some of the important library functions which are rarely used but very crucial while you are doing projects. So let me start with my first function, that is map. This function is used to map a value from one range to another. Look at the syntax. How we write it? It's x equal to map within bracket y, fl, fh, tl, th. Here the value of y will be mapped and stored in x. Value of y is in the range of fl and fh, and that is the source range where fl is the lowest value and fh is the highest value. TL and TH, where TL is the lowest value of the destination range and TH is the highest value. For a better understanding, see this example. Here x is the variable whose value will be mapped and stored in y. The current range of x is between 0 to 1023 and x will be mapped into a range of 0 to 255. So when the value of x is 512, the mapped value will be 128. How? 512 is the middle point of the range 0 to 1023 and 128 is the middle point of the range 0 to 255. The mapped value will be stored in y. You may ask where we can use this map function. Let me give you an example. Suppose you want to control the brightness of a LED through a potentiometer. You have learned how to read potentiometer values in analog read lesson. You have also learned how to control the brightness of a LED using analog write. So the simple solution can be just copy the value to analog write function what you are reading from analog read function. But there is a catch. The range of analog read values is from 0 to 1023 and the range of analog write is from 0 to 255. You should use something to convert the range. That something is the map function. I have written this piece of code here where I have initialized a variable value where the ADC readings will be stored. The value is then remapped using this map function and the result is stored in the same variable. That's why I have written value equal to map within bracket value. Then I am directly copying the value inside analog write function. That's how you can do this application. I think now these function details are clear to you. So let's move on to our next function, that is pulse-in. Pulse-in is used to read the duration of high and low pulses. It returns the duration in microseconds. Look at the syntax, how we write pulse-in function. It's y is equal to pulse-in within bracket parameter 1, parameter 2. Here parameter 1 is the pin number where you want to read the pulses. And parameter 2 is the pulse type. It can be either high or low. See this pulse. The pulse has an on time of 10 milliseconds and off time of 7 milliseconds. And say this pulse is coming at pin 8. Then what? If I write y equal to pulse-in within bracket 8, high, then the function will read the duration of high time and returns the value in microseconds. In that case, what will be the value of y? Can you tell? You can pause the video here and think. Let me give you the answer. It will be 10,000 microseconds. And 10,000 microseconds is equivalent to 10 milliseconds. If I write y is equal to pulse-in within bracket 8, low, then the value of y will be 7000 microseconds in our case. If these two answers match with your calculations, then you have the clear concepts of pulse-in function. Let's move on to our next function, that is analog reference. Analog reference is a function which is used in ADC operations mainly. Remember, I have told you that the Arduino Uno can read a voltage range of 0 to 5 volt in analog inputs. Do you know that range can be modified? Isn't that a great feature? That thing can be done using analog reference. So how we can write analog reference? It's simple. Analog reference within bracket, mention the type. We should write this function inside void setup. That will be better. There is only one parameter, that is the type of the reference. The types can be default, internal and external, all in capital letter. Default is the default settings where the analog read will read up to 5 volt and gives 1023 when it reads a 5 volt. If you set it at internal, then internal is the settings where analog read will give 1023 when it reads a 2.56 volt. That is internally set. It will happen if you select the type external. The same thing will happen if you select the type external, but this time you have the freedom to choose any voltage between 0 to 5 volt. You should give that voltage at analog reference pin. Now where you can find this pin? Beside the ground pin. Look at the image. I have marked the pin. If you have an Arduino Uno board, then you can physically check that too. So for an example, if you choose 3.3 volt and put it at analog reference pin, then it will give you, the Arduino Uno will give you 1023 when it reads a 3.3 volt at any of the analog inputs. Understood? Now let's move on to our next function. Our next function is tone function. So tone function is very simple. Look at the syntax. It's tone within bracket, pin number, comma, frequency in hertz. So this tone function is one of the essential function where you can generate a square pulse from any of the pins available in Arduino Uno board. So by square pulse, I mean a pulse of 50% duty cycle. So the on time and off time will be same. So tone can be generated at any of the pins. So you can write from 0 to 13, you can use any of the pins, and frequency will be of your choice. You can write 1000 if you want to generate a 1 kilohertz pulse. So tones, once generated, will continue releasing the pulses from the pins. If you want to stop the generation, then you can use this function no tone, where T will be in capital and within bracket you can mention the pin number. See this example. Suppose I want to generate a 1 kilohertz square pulse from pin number 11, then I can simply write tone within bracket 11, 1000, where 11 should be configured as output. Remember this, 11 should be configured as output, and if you check the oscilloscope at pin number 11, you will see that the pin 11 is generating 1 kilohertz pulse. Once the controller has executed this function. Now let's move on to our next function, that is delay microseconds. This function is one of the useful functions, library functions. You have till now you have used the delay function, but delay microseconds works in a similar way, but here the delay can be mentioned in microsecond. So what happened in the case of delay is we write delay within bracket, we give a value in milliseconds. But in case of delay microsecond, we have to give the value in microseconds. Suppose we want to generate 1 millisecond of delay, then you can use this function in this way. Delay microsecond, m is in capital, within bracket 1000. It will generate a delay of 1000 microseconds, and that is equivalent to 1 millisecond. This is how the delay microseconds work. Now let's move on to our next function, that is millis. Now this is very important function, so you should understand this in a clear way. So millis is the stopwatch for Arduino. Whenever your Arduino board is powered up, the millis function gets activated and it will start counting the milliseconds. It will run till the Arduino is powered on. In that span of time, whenever you want to know the time since Arduino is powered up, millis will return the time in milliseconds. So it is a return type function which returns a long variable. How we can use this? We can simply write x equal to millis. Then x will store the value in milliseconds since the Arduino is powered on. You can also check the timing in other ways. Let me give you an example. You can also use this millis timings in other ways. Let me give you an example of LED blinking with millis. If you see this, concepts of millis will be very clear to you. Look at this code. This is a simple LED blinking code. Here I have written the piece of code. Now look at carefully. First I have mentioned pin number 13. I have defined pin number 13 as LED, and I have defined one variable called pre-millis. Now inside void setup, I have declared, I have configured the pin LED as output, and I have written pre-millis equal to millis. Now here the pre-millis will store some kind of millisecond value. Now come to void loop. There is an if statement within bracket millis minus pre-millis. Now here pre-millis is holding a value. There is a value stored in pre-millis, and millis is a stopwatch. It is counting. Suppose pre-millis have a value of 500. Say 500. Now millis is counting. Millis is counting 1, 2, 3, 4, 5, 6, 7, 8. Like that, it will count, and when it will reach 1500, then 1500 minus 500, that will be 1000. And when it crosses 1000, then it will go inside the if statement. And here I have mentioned one line. You are seeing this for the first time. It's digital write within bracket LED comma not digital read LED. So what it will do is it will toggle the LED. How? So first it will read the status of LED. Now for an example, suppose LED is off. In first state, LED is off. If I assume that, then digital read will give an output of low, and not low is high. So digital write within bracket LED comma not low, that is high. So LED will glow. The next time it comes inside this if statement, then LED status will be high, and not high is low. So digital write within bracket LED comma not high, that means low. So LED will be off. Each time it will toggle the LED. That's why I have written this statement. Now here I am swapping the value of pre-millis. So I am giving a new millis value to the pre-millis, because millis is still counting. So I have to swap that value, otherwise this if statement will not work. Now you can practice this as an assignment. So I am giving you this assignment, and let's move to our next function, that is micros function. Micros works similarly like millis, but here in this case it will return the value in microseconds. So see this example. If I write long x equal to micros, then X will store the total time in microseconds since the Arduino is powered up. It's very similar to millis. Now our next function is println function. So println function is used in case of serial object. So how we write it? We write serial.println within bracket any value. But here I'm telling you one hack. You can say this is the Arduino hack. So here I can directly write serial.println within bracket a float variable, comma, precision. Suppose for an example, in my program I have written float pi equal to 22/7. Normally you can check in your calculator that what will be the value. The pi's value can be 3.142857 like that. If I write serial.println within bracket pi, it will print only 3.14 up to 2 decimal places. But if I write serial.println within bracket pi comma 6, then it will print up to 6 decimal places. It will print 3.142857. So in that way you can display the precise floating point values. So if I write serial.println a floating point variable, comma, up to how many decimal places I want, I can mention that. And that way the Arduino can print a number of precise floating point values. So this is one of the hack. So up to this you have learned so many things. So in next section I'll tell you how to interface obstacle sensor with Arduino, how to interface temperature sensor with Arduino, how to interface a light sensor with Arduino, and how you can control the RGB LED, and how to program the interrupts in microcontroller and what is an interrupt. I'll tell you all of that in the next section.